Example 5. A parallelogram has sides of length 25.9 centimeters and 32.5 centimeters. The longer diagonal has length 57.8 centimeters. Find the measure of the angle opposite the longer diagonal. Round to the nearest tenth. All right, so we need to draw this parallelogram out. Okay, so what a parallelogram is, it's basically a four-sided object and you've got a pair of parallel lines. Okay, so maybe it looks something like this. I don't know, maybe here. And then this side is going to be parallel to this side. Okay, and then you've got the other two sides are also going to be parallel. Okay, so maybe it looks like this, and then these two sides will be parallel. Okay, so like that and like that. Okay, so here's our rough sketch of a parallelogram, and we know this side has to equal the length of this side. The length of this side has to equal the length of this side. Okay, now we are given these lengths. Okay, so there's a shorter length and there is a longer length, and so just from the way I've drawn this, the red lengths are shorter than the blue sides, so the red sides are going to be 25.9 centimeters. Okay, so this has to be the same measure. Both red sides have lengths of 25.9 centimeters. The blue lengths, those are the longer sides, they both measure 32.5 centimeters. Okay, so this is what our parallelogram looks like. We know some additional information about the diagonals. Okay, so basically if I draw in the diagonals, I'll draw one in black and one in green. Okay, so this is the shorter diagonal. Okay, so I'll write that out. This is the shorter diagonal. And then there is a longer diagonal. Okay, so that's going to look like this. Okay, so this is the longer diagonal. And let's see, what do we know? We know the longer diagonal has length 57.8 centimeters. Okay, so we know the length of the green one, so that's 57.8 centimeters. Okay, we want the measure of the angle opposite the longer diagonal. Okay, so here's what we're looking for. Find the measure of the angle opposite the longer diagonal. Okay, well, the longer diagonal is the green diagonal. We want the measure of the angle opposite the longer diagonal. So the angle that we're looking for here, let me use a color that stands out. If you see the green diagonal and you go straight across from it, it's going to be this angle. Okay, now this angle has the same measure as this angle. Okay, so that is the angle we are looking for. All right, we need to figure out which case this is. Is it SAS? Is it side, side, side? Is it side, side angle? What is it? Okay, well, our parallelogram has been broken up into a number of triangles. Okay, we're after the orange angle. So if I do some shading here, let's see. The orange angle is part of one of these two bigger triangles, so I'll just shade one of them. Okay, so here, if I shade this triangle, the orange angle is part of this triangle. It's one of the three angles in this blue triangle. Okay, so let's concentrate on that. Okay, if we look at this larger triangle, what do we know about it? Okay, well, we actually know the measure of all three sides. Okay, if you follow my cursor, we know this side length is 32.5 centimeters. We know this side length is 25.9 centimeters. And then this longer diagonal, that's the bottom of the triangle or the base of it, that's 57.8 centimeters. Okay, so this is actually a side, side, side. Okay, so if we know all sides, we need to use the law of cosines. Okay, so this is going to be law of cosines. And we're solving for one of the angles, obviously, because we know all the sides. Okay, so we have to be solving for one of the angles. Okay, let's go ahead and put A, B, and C on this thing. Okay, it doesn't matter which point you call A, B, or C, just pick something and stay consistent. I'll go A, B, C. Okay, so if we go across from angle B, okay, if you draw angle B is this entire orange angle. So the entire opposite side is the 57.8 here. Okay, so this is going to be side length B. Okay, and then if we go across from angle C, okay, here's angle C. If we go across from it, okay, that means that the 32.5 centimeters, that's the C length. And then if we go across from A, here's angle A, okay, we go across from it, that means the 25.9 is side length A, okay? So we need to go back to the law of cosines and figure out which version to use, okay? So if we look at law of cosines, let me find it, it is down here, okay? So law of cosines, the way I've got this thing drawn, if I look at it, the way I've got it drawn is I'm looking for angle B here. Okay, so here's angle B. We don't know what it is. Okay, if we go back to law of cosines, I need to choose the second statement again because it involves angle B. Okay, so here we go. So I need to write down the law of cosines. This is going to be B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of B. Okay, so we've worked with this in a previous example. Where after B, it's up to you if you want to go ahead and plug everything in, or we can solve for the cosine of B and then plug everything in. Okay, and that's generally what I do, but you do whatever makes you happy. Okay, so I need to isolate this thing in yellow, so I'm going to move the A squared over, I'm going to move the C squared over, so I'm going to subtract these guys from both sides. That's going to tell me that B squared minus A squared minus C squared equals negative 2 times A times C times the cosine of B. All right, so now cosine of B is just multiplied by negative 2 times A times C, so I can divide that quantity off. Whoops. So whatever I do to one side, I have to do to the other. So this gives me a way of calculating the cosine of B. Okay, so I'm just going to write it here, reverse the sides of the equation. Cosine of B is equal to B squared minus A squared minus C squared all over negative 2 times A times C. Okay, I'm going to plug into this, okay, and then go from there. Okay, so here we go. The cosine of B is equal to side B squared. Okay, so side B is 57.8 squared minus A squared. So side length A is 25.9 squared minus side length C squared, which is 32.5 squared. Okay, all over negative 2 times A times B. Okay. All right, so I'm going to go to my calculator and punch this in on the right side, and that will give me a decimal approximation for the cosine of B. Okay, so here we go. The numerator is 57.8 squared minus 25.9 squared minus 32.5 squared. Okay, so this is the numerator, and then I need to divide by this denominator. Okay, make sure if you have an older calculator that when you divide, you put the entire denominator in parentheses. So the denominator is negative 2 times 25.9 times 32.5. Okay, put that in parentheses just to be safe. Okay, so here comes the cosine of the angle. I'm going to write out the full decimal expansion. You will need it for accuracy. Okay, so the cosine of B is going to be negative 0.958562786. Okay, we're after angle B. Okay, it is trapped by the cosine, so to undo that, we're going to take the cosine inverse of both sides. Okay, so let me write this out for you. Okay, so we're going to have the cosine inverse of the cosine of B is equal to the cosine inverse of this long decimal, and you do, like I said, need to use all the digits for accuracy. okay? On the left, the cosine inverse and the cosine will cancel, leaving you with angle B, okay? So I'm going to go to my calculator and I am going to take the cosine inverse of this decimal. Make sure you're in degree mode. You can either retype the whole entire decimal expansion or just call up the previous answer, and let's see what we get. Okay, this is going to be the measure of angle B. So let me write down the full decimal expansion and then we'll round it. Okay, so 163.4529,689. Okay, that many degrees. Okay, and based on our picture, it looks pretty, it looks like a reasonable answer. We are told in the directions to round to the nearest tenth. That's one place after the decimal point. So we have 0.4. There's a 5 that comes after it, so we need to bump it up to 163.5 degrees. Okay, that's the measure of the angle. I'll write it up here. The angle we're looking for is approximately 163.5 degrees. We are done.